My name is Amy Huff, and I'm a research scientist at Pennsylvania State University. I'm also an air quality forecaster for the Philadelphia metropolitan area and the state of Delaware. Today I'm going to provide an overview of NOAA's eIDEA website, which is a decision support tool for monitoring and tracking the impacts of fire and smoke. eIDEA stands for Enhanced Infusing Satellite Data into Environmental Applications. It grew out of NOAA's IDEA website, which has been in use for many years as a near real-time and archive visualization database for NOAA and NASA aerosol-related satellite products. Here is the eIDEA URL and homepage. Note that you can also find eIDEA by Googling NOAA eIDEA, which is easier than typing in this long URL. eIDEA was developed to specifically address the needs of forecasters who require timely data and imagery in a simple, easy-to-use interface. eIDEA was designed to be very simple and uncluttered. The basis of eIDEA is a Google Maps zoomable visualization of the satellite data. The imagery are available in near real time with a calendar to access an archive of previous day's imagery. The main data products are available as overlays, controlled by buttons on the right side of the homepage. Additional buttons above the main overlays provide links to satellite data animations and additional information. The current domain of eIDEA includes the CONUS, most of Canada, and Alaska. There is a separate page just for Alaska users called eIDEA Alaska, which is available under the external links. The domain of eIDEA will be expanding soon to include Mexico, Central America, and the Atlantic Ocean. Here is a list of the products on eIDEA. Most of the data on eIDEA are fire and smoke products from the VIIRS instrument on the SNPP satellite. All of these products are reviewed in detail in a separate tutorial. There is also an overlay of ambient surface fine particulate matter, PM2.5, concentrations from US EPA's Air Now Monitor network, which are useful for indicating whether smoke is reaching the surface. eIDEA has several animations available, which are useful for showing the transport of smoke plumes and the evolution of fires. The primary data products on eIDEA are available as overlays. The default is the VIIRS True Color Imagery, abbreviated RGB, overlaid with the VIIRS Smoke Mask, the pink colors, and the Fire Radiative Power red hotspots. Click the buttons at center right to switch between smoke products, including the Smoke Mask, Aerosol Optical Thickness, abbreviated AOT, and Satellite-Derived PM2.5. Move the slider bars to adjust the opacity of the true color or smoke imagery. Add or remove additional overlays using the buttons below the slider bars. Options include the Fire Radiative Power FRP hotspots and the observed surface PM2.5 concentrations from US EPA's Air Now network. Legends for all of the product overlays are located at the top of the page. For a refresher on the data products, click on the product description at the top of the page. Once you have a configuration that you like, you can save the image to your computer using the Save Image button at the bottom right. eIDEA is built on a Google Maps interface, so it is easy to navigate. Zoom into an area of interest using the plus or minus buttons, or scroll forward or backward with your mouse. You can also double-click to zoom in. Today is the default when eIDEA opens. To select another day, click on the date near the top of the page to open the calendar. Use the arrow buttons in the calendar to change the month. Click on a specific date to select it. Note that today is shaded yellow. You can also use the arrows on either side of the select date to load data for the previous or next day. When you do that, the configurations you have selected won't change, which makes it easy to scroll through various days in a smoke event. eIDEA also has additional visualization tools. You have the option to add county boundaries. This is most useful when you are zoomed in, which appear in gray. And you can turn the local, state, and national labels and boundaries on and off if you would like to see the aerosol data on an uncluttered background. Unfortunately, I can't do a live demo of the website in this tutorial, but I will try to give you some examples of how to use eIDEA to analyze a smoke event. Let's look back at the beginning of the Sobranos fire in Monterey County, California. To access archived imagery, click on the Select Date window at the top of the homepage, and then use the calendar to navigate to the day of interest. In this case, July 24, 2016. And then we can zoom into our area of interest, in this case, California. The default is true color or RGB imagery overlaid with the smoke mask and the fire radiative power hotspots. Here I have turned off the FRP hotspots so you can see the smoke mask clearly, the pink and magenta almost red colors indicating the presence of smoke. You can see the smoke in the RGB image as well as the white clouds of the marine layer along the coast. By adjusting the smoke products opacity slider bar, in this case all the way to the left, you can dim or hide the smoke products and just see the true color image. Here is the true color image with the red fire radiative power hotspots overlaid. They show the fire detections. The fire intensity as fire radiative power is given by the size of the red dots. In the true color image, you can see the thick gray smoke associated with the fire. Now I've slid the smoke products opacity slider bar all the way back to the right, and I've clicked on the AOT button to show the aerosol optical thickness. You can see the red colors of high AOT associated with the smoke plume and the red fire radiative power hotspots overlaid, showing the locations of the fire. Now I've moved the RGB opacity slider bar all the way to the left so I can see the AOT data on a black background. Now I've brought back the true color imagery and I've clicked on the county button to add the county boundaries shown in gray. Now I've removed all borders and labels by clicking on the labels button to see the true color imagery, smoke mask, and fire hotspots on an uncluttered background. Let's change the date and location to look at another feature of eIDEA, the satellite-derived PM2.5 concentrations. This is now May 21, 2016, when dilute smoke from the Fort McMurray fire, burning in Alberta, Canada, had drifted into the Midwestern U.S. The satellite-derived PM2.5 product gives an idea of the health impact of smoke. The product legend, shown at the top, corresponds to PM2.5 concentrations in units of micrograms per cubic meter. Orange and red colors correspond to PM2.5 concentrations that exceed the National Ambient Air Quality Standard, or NAAQS, for PM2.5. On May 21st, you can see the dilute smoke had slightly increased PM2.5 levels, but only to the yellow range. Ambient surface PM2.5 concentrations from the AirNow network are available as an overlay and appear as colored dots, using the same scale as for the satellite-derived PM2.5. The AirNow PM2.5 dots show locations where smoke has mixed to the surface, and they also indicate the accuracy of the satellite-derived product. In this case, on May 21st, the satellite-derived product was able to capture the distribution of surface PM2.5 concentrations relatively accurately. eIDEA has two different types of animations to help show the transport of smoke plumes and the evolution of fires. Access the animations using the buttons on the top right side of the home page. At any time, you can click the Home button or the eIDEA logo to return to the home page. There are links to additional documentation, mainly about the aerosol algorithm, and links to the NOAA Hazard Mapping System Fire and Smoke product page, as well as the original IDEA page and eIDEA Alaska. This is a snapshot of the trajectories animation. The trajectories are designed to show the forward movement of high aerosol plumes. The bottom line is that where you see magenta trajectories, smoke plumes are expected to impact the boundary layer. For more information on the trajectories, see the separate tutorial on Veer's aerosol products and read the product description available by clicking near the top of the page. Product legends are at the bottom of the page. The trajectories animation is on a Google Maps interface, just like the main eIDEA page with the overlays. Zoom into an area of interest using the plus or minus buttons, or scroll forward and backward with your mouse. You can also double-click to zoom in. The animation controls allow you to start, stop, reverse, and fast forward the trajectories. The other set of animations available on eIDEA is the 3-day movie loops, showing the Veer's smoke mask and fire radiative power hotspots on the upper left, satellite-derived PM2.5 and ambient PM2.5 colored dots on the upper right, and the Veer's aerosol optical thickness on the bottom center. The default region is the CONUS, but you can select a regional subset by clicking the appropriate thumbnail at the bottom of the page. There is also a link to known issues on the eIDEA homepage. There is one current issue that I'd like to review. There can be artifacts in the smoke mask and AOT images over regions where VIIR's swaths overlap, such as the central US. Some parts of VIIR's images may be hidden due to the overlapping of the swaths. As a result, it sometimes looks like data are missing on eIDEA. This is caused by two separate issues. Number one, different sun satellite geometries can cause the smoke mask algorithm to retrieve different results. And number two, there can be inconsistencies between the way the smoke mask is displayed on eIDEA compared to the true color imagery. Let me show you how this works with an example from August 2015. This slide shows VIIR's true color or RGB imagery overpasses on August 21st over the central United States. There are two overpasses for the region indicated by the red circle in the bottom image. Overpass 1 was at 1840 UTC, shown on the top right, and Overpass 2 was at 2020 UTC, shown on the top left. On eIDEA, the true color image from Overpass 2 is plotted on top of Overpass 1, as shown in the bottom image. So we are only seeing the true color image from Overpass 2. But the smoke mask is displayed differently. In this slide, you can see the same two overpasses as in the last slide, but because of the different solar satellite geometries, the smoke mask algorithm obtained different results for the overlapping region. In this case, much less smoke was detected in Overpass 2. eIDEA handles this type of discrepancy by plotting the smoke mask data from Overpass 1 if no smoke mask was detected in Overpass 2. eIDEA does the same thing in cases when AOT data are missing from the previous overpass. In this way, eIDEA can show more retrievals in the imagery. However, this approach can introduce artifacts in the smoke mask and AOT imagery, so the user should be aware of data inconsistencies along areas where swaths overlap. The eIDEA website will be updated after the launch of the GOES-R satellite in November 2016. GOES-R is the first in the next generation of geostationary Earth-observing satellites. It will have a sensor similar to VIIR's called the Advanced Baseline Imager, or ABI, that will be capable of providing aerosol observations every 15 minutes over the full disk of the Earth, covering North and South America. In this way, the GOES-R ABI will provide nearly continuous, high-accuracy aerosol observations of the atmosphere over the Western Hemisphere. The GOES-R ABI will also be able to scan the CONUS every 5 minutes in certain situations. Critical events such as wildfires will be monitored in a special mesoscale mode that will provide a rapid update of observations every 30 seconds. With aerosol and cloud imagery available at 30-second intervals, data from GOES-R will become indispensable for forecasters who need to assess the impacts of smoke to help protect public safety and air quality.